Nuclear energy is a carbon-neutral energy source and is adopted worldwide in the fight against climate change. For example, here in Ontario, almost 60% of our energy comes from nuclear. Now, regardless of your position on nuclear energy, we can all agree that the waste generated over the last 60 years must be carefully managed. The current plan in Canada is to isolate the waste in a deep geological repository with a multi-barrier design to protect its release to the environment. I work together with the Nuclear Waste Management Organization on the design of the used fuel container, which is the primary containment barrier. I studied the corrosion of the copper coating of the container under accelerated conditions. I tried to understand how the chemicals that are in the repository will affect the corrosion performance of the container. Now, in my research, I made an important discovery. Chloride, the main component in table salt, is normally quite detrimental to the corrosion performance of many materials. However, for the copper coating, it might actually be very beneficial. We have shown that chloride can adsorb onto the copper surface to form a protective layer that prevents it from corroding. And we've also developed a method to quantify how much chloride is needed to stop corrosion. And it turns out that it's less than 1 parts per million. So this work is important because it means that if there's chloride present in the repository, which there will be, it will protect the container from corrosion. Now, chloride is normally the corrosion villain, but in the context of nuclear waste management, it has become the hero. Thank you.